Hello friends, Sri Bahubali Vidyapit Bahubali online teaching class standard 9th semi maths 1. I welcome all of you for the unit number 2 real numbers. Number, we know that number is the mathematical object which is used to count anything. Here in these real numbers we are going to study what is the meaning of real numbers. Before that we have studied the natural numbers, that is 1 plus 2 equal to 3, 2 plus 3 equal to 5. So these real numbers are represented on the line. If we add 0 in natural number, then it becomes the whole number, that is 0, 1, 2, 3, 4. So natural number plus whole numbers does not include minus 1. Hence, natural number plus whole numbers forms the real numbers. Real numbers are classified mainly in two types, rational numbers and irrational numbers. So the numbers which are in the form of ratio are the rational numbers, and not in the form of ratio are irrational number. So rational numbers are represented p by q, and the second type is the integer, which includes the rational number, that is negative integers, 0 and positive integers. So in integers we consider the natural numbers as well as the whole numbers, but in case of the irrational numbers we have root 2, root 3, pi. These are the irrational numbers. So real numbers can be mainly studied in the rational and irrational numbers. So these real numbers are represented by Venn diagram. Real numbers, that means p and q.
What we're going to talk about now is just different classifications of numbers, okay? And more specifically, what we want to talk about is real numbers, which are basically any number that can be written on your number line. Okay, so if your number line is just a spectrum of numbers, you have the numbers like 0, 1 on there, but you also have a number of different numbers in between there, okay? And so we're going to talk about the different breakdown on all the classifications of those numbers. So where I want to start is on natural and counting numbers. And basically what those are the numbers 1, 2, 3, so on and so forth. 842, any sort of number that is a whole number larger than 0. Okay. Whole numbers include 0. So basically a whole number is a counting number plus 0. And they continue upward as well. Integers include the negative spectrum. So you are going up to say -2, -1, 0, 1, 2, so on and so forth. Okay, so we have our counting numbers, only positive. Whole numbers throw in 0. Integers throw in negatives. The next part is what we call rational numbers. And rational number is any number that can be written as a fraction. Okay, so this can get a little bit tricky because a number like any integer can be written as a fraction. -2 can be written as -2 over 1. Therefore, it can be a rational number. That also includes things like 1/4 or 0.23, because 0.23 can be written as 23 over 100. Okay? Basically, any number can be written as a fraction. The last thing are what we call irrational numbers, which can't be written as a fraction. And examples of those are, say, like pi, remember pi from geometry, or something like the square root of 3, anything like that. Okay? So whenever we're dealing with different types of numbers, this is just some language that we are dealing with. Okay? And one thing to be aware of is we can often simplify things up to put them into a category they may not appear. Like we're used to saying, okay, radicals are irrational, square roots. But something like the square root of 36, we know what that is. So therefore, that square root doesn't have to be there because the square root of 36 is actually 6, which would then put it into all three of these categories. Okay? Say like 2/4. You can simplify it to 1/2. It's going to be a fractional number. That actually didn't change too much, so never mind that example. But something like 8/2, you can simplify that to 4. So it's not just a rational number, it can also be a integer, whole number, or counting number as well. Okay? So just sort of looking at your classifications, always make sure you simplify it before you jump to a conclusion as to what type of number it is.
So here we have given the n set of the natural numbers, w set of whole numbers, I set of integers, q set of rational numbers. So here we have given the properties of rational number, that is commutative property, associative property, identity. Here we have given one example to express the recurring decimal in p upon q form, that is express the recurring decimal 0.777 into p upon q form. We have solved it. Second one is the express the recurring decimal 7.529 in the form p upon q, that is solved here. So now try the practice set 2.1. Here we have studied what is meant by number, and do it in home. Thank you.